Now, when I saw the problems for this month's mini, I went to the other guy, the guy who usually does these videos, and I said, hey, yo, take a break for a month. I got this. Now, I did that because I've seen that other dude do problems like this. It's not pretty. You know, I go to the national countdown round with him every single year. And whenever problems like this come up, he completely freaks out. Because the kids on the stage are like, boom, buzz in, right away they got the right answer. And that other dude, he's like, they must be cheating, they must be using calculators. I tell her, there's no way they're using calculators. They can't hit the buttons that fast. I've seen them play PlayStation. No, they got something better than calculators. They got their brains. So we're going to take a look at how those brains are working when they're solving problems like this. And then maybe that other dude watched this video and learned something. So here we go. We got a problem like this. We got these big numbers. Now, I can't always see the patterns through these big numbers because I can't see much of anything with these glasses on. So what I'm going to do here, I'm going to do something that other guy really likes. I'm going to throw some letters in here for these numbers. Other dude likes letters because, you know, he talks too much. So we're going to throw in some letters. We're going to throw in an X for 13, 13. We're going to throw in a Y for 12, 12. And we get X squared minus Y squared. And there we go, difference of squares. That's a pattern we recognize. We know that we can factor that. That's just X plus Y times X minus Y. So you don't buy it? Ah, you want me to prove it to you? That's very cool. Don't trust, so we have to verify. So I'm gonna show you why this equals that. We're gonna break out the distributive property, multiply that out. We get X times X minus Y plus the Y times the X minus Y. And watch this cancellation happen. X times X gives us X squared. X times a minus Y gives us minus XY. Then we got the Y times the X over there gives us a plus XY. Y times the minus Y gives us the minus Y squared. And there's that nifty cancellation right there. These go away. So this product is X squared minus Y squared. So here's the next trick. We take our big numbers, we stick them back in for the letters. 13, 13 goes in for X, 12, 12 goes in for Y. X plus Y becomes 13 plus 13, 13 plus 12, 12 gives us 25, 25. And then 13, 13 minus 12, 12, that gives us a 101. Now this is something you can probably multiply out in your head. The way I multiply this out in my head is I break out a little distributive property once again. I got 25, 25 times 100. That gives us 252,500 plus the extra 25, 25. Add those up. You get 2,5,0,2,5. And we are finished. While that other dude, he's still squaring out the 13, 13. We're going to move on to the next problem. Here we go. Whew, okay, these numbers aren't as large as the other ones, but we're still not going to square out that 444. Well, we see that difference of squares right there. We're going to throw in the letters again and see what happens. We're going to put in an X for 444, a Y for 111, and we'll see that this looks like X squared minus Y squared divided by X minus Y. Now, I'm not even going to subtract out this 444 and 111 yet. I'm going to throw in these variables, see what pops out. Once again, we remember this difference of squares thing. We can factor that. Factoring is awesome. We factor that as X plus Y times X minus Y. Again, all divided by the X minus Y. And now we see how nice it was that we didn't do the subtraction right away, because now the cancellation's very, very clear. We cancel these two factors. We just have X plus Y. X is 444. Y is 111. Our answer is 555. And we are moving way past that other guy. On to the next problem. You know the drill here. I don't see a difference of squares. I see some kind of large numbers. Don't want to square out the 133. Let's throw in the letters again. We'll put in X for 133. We'll put in Y for 67. And we have X squared plus 2 times X times Y plus Y squared. Now, maybe you recognize this. This is the expansion of the square of X plus Y. Yeah, I know. You don't buy it, so I'll go ahead and prove it to you. And you know how we're going to do that? We're going to break out the distributive property once again. We're going to go ahead and multiply this out. We get X times X plus Y times X plus Y. Multiply this out, we get the X squared. We get a plus XY here. We're going to get another plus XY right there. So that gives us 2XY. And then we get the Y squared at the end there. So this X plus Y, quantity squared, gives us that right there. And we see right up here, we put in our 133 for X. we put in our 67 for y. And this messy expression up here simply equals 133 plus 67, that quantity squared. Conveniently, that 133 plus 67, that's just 200. So we have the square of 200, which is 40,000. You know what? I'll bet that other guy still squaring out 1313. Let's go on to the next problem. Oh, what is this? Okay, we got a multiplication table. And remember back in elementary school, they make you fill these things out over and over and over. I don't want to fill that out again. I did that enough way back when I was in elementary school. We won't talk about when that was. But this problem wants us to fill out all the numbers in the grid and then add them all up. I mean, those aren't particularly big numbers, but there are an awful lot of those little numbers, and adding them would take all day. What are we going to do here? Well, I know what the other dude would do. He'd be sitting here going, okay, 1, 2, 3. He'd be having a field day with that, but I'm way too lazy for that. So we're going to find something smart to do here. All right, what's this first row? Let's see here. This first row, we're just taking the 1, and we're multiplying it by each of these numbers up here. So this first row is just 1 times 1, then times 2, then times 3. So I'm going to take all this sum here. I'm going to factor that 1 out, and I'm going to write it as 1 times this sum. Now, if I expanded this product, I'd have 1 times 1, 1 times 2 right there, 1 times 3 right there, and so on and so forth. But I'm going to factor out this 1 because in the next row, something cool happens here. I'm going to put in that 2, 4, 6. That other guy understands what's going on this row. Now, if I factor out the 2 that's along this row, I get 2 times 1 plus 2 plus 3, and on and on and on. And if I multiply this out, I get 2 times 1, that's this. 2 times 2 is this. 2 times 3 is this. 2 times 4, so on and so on and so on. That gives us this row. And we can see that that's what each of these rows is going to look basically just like this. The next one's going to be 3 times 1 plus 2. And all we're doing here is factoring. We're just factoring out the number at the beginning of each row. And we see that what's left after we factor out these leading numbers is always the same. It's always the sum of the numbers from 1 through 9. This big mess over here. Well, this big mess, we can kind of treat it just like we treated the big numbers in the other problems. We can just throw in a letter for it. I'm going to call that x again. So we can think of this row as just 1x, where x is this big sum. This one is just 2x, and this one's just 3x, and then 4x, 5x, 6x, all the way down to 9x, and then we have to add them all up. So when we add all these up, it's just like adding 1x, 2x, 3x, all the way up to 9x. When you add that all up, what do you get? You get x times the sum of 1 through 9. 1 plus 1x, 2x, 3x gives us, add it all up, we get the sum of 1 through 9. We add all these up. So sum of 1 through 9 times x, but x was just this big giant expression right here, which was also the sum of 1 through 9. So when we add up all these numbers in this big giant grid, we just get the sum of 1 through 9 times the sum of 1 through 9. Well, the sum of 1 through 9 is easy. 1 and 9 is 10, 2 and 8 is 10, 3 and 7, 4 and 6, they're all 10. Then you got that extra 5. So you got 45 here, 45 there. So our sum just equals 45 squared. Now I multiply that out in my head using that same thing from the last problem, that square of a binomial, 40 plus 5. We take that quantity squared, we get 40 squared plus 2 times 40 times 5 plus 5 squared. The 40 squared is 1600. 2 times 5 is 10 times 40 is 400. 1600 plus 400, that gives us 2000, plus that extra 25 right there gives us our final answer of 2025. And once again, we see the power of factoring here. Next time you see that other guy, tell him about it.